Okay, we're going to start talking about distance and displacement, and we're starting with distance. And distance is nothing more than the length of the path taken from the starting point to the end point. It is a scalar, so it has magnitude only. It's given the symbol S or D, and two examples would be 8 meters and 25 kilometers. Next, we're going to talk about displacement. Displacement is the straight line distance from the starting point to the end point. It is a vector, so it has magnitude and direction. It's given the symbol S with an arrow over it, indicating that it is a vector. And two examples would be 80 kilometers west, 3 centimeters south. And here's a little diagram to show you the difference between distance and displacement. Displacement, straight line distance from starting point A to ending point B, as opposed to distance, which would be the red line or the blue line. Do a quick example to see how to calculate distance and displacement. We're starting with a little simple example, and it's a bird who flies 5 kilometers north, then 12 kilometers west, and we want to find this distance and displacement. To do so, we're going to use a vector diagram. So we start with a direction indicator and a scale. We draw our vectors, 5 kilometers north, 12 west. A resultant is drawn from the tail of the first to the head of the last. And we have a reference angle theta, so we can actually get a direction for our vector. Now to do this, we need to find a distance first. The distance is merely the sum of the two legs and the magnitude of each of these vectors. 5 kilometers plus 12 kilometers for a distance of 17 kilometers. Next, we want to find the magnitude of the resultant, r squared. And we're going to use a Pythagorean theorem, so we start with that. We substitute in our values, 5 kilometers squared plus 12 kilometers squared. And my suggestion is you actually write this out on a piece of paper. I know it's easy just to plunk the numbers into your calculator and push the enter or the equal sign, but in case you make an error, you have no way to backtrack. Now, while this problem is nice and simple, you are obviously going to run into more complicated problems that will leave you stunned when you try to figure out where your error is. We get an r squared here of 169 kilometers squared, and we get a magnitude of our resultant of 13 kilometers. Remember, that's only the magnitude of the resultant. Next, we're going to find the angle theta, and we're going to use the opposite over the adjacent. So theta is equal to the inverse tangent of 12 kilometers divided by 5 kilometers. We put those numbers in our calculator and we get an angle of 67.4 degrees. Now we need to generate our vector here, and here we see it. Our vector has a magnitude of 13 kilometers and an angle of 67.4 degrees. And here we want to remember that on a map, north is 0 degrees and east is 90 degrees. So we don't need to use any other description of this direction.